A very good morning, one and all. Welcome to this session number 26. So, in this session, we will learn about how to solve problems on resonance circuit. Problem 1. In a series LCR circuit, if the resonant frequency is 7000 Hz and the bandwidth is 10,000 Hz, calculate the quality factor. So the quality factor is nothing but the ratio of resonating frequency to the bandwidth, which is 7000 divided by 10,000 will give you about 0.7. Please note that quality factor Q is a dimensionless. Problem number 2. An AC circuit containing a resistor of 100 ohms, an inductor of 5 millihenry and a capacitor of 100 microfarad connected in series, calculate the resonant frequency. So we know that the resonating frequency is given by nu r is equal to 1 over 2 pi square root of L into C. Substituting the value of 2 pi L and C, we obtain 711.7 Hertz. Problem number 3. An inductor of inductance L is equal to 1 by pi Henry is connected to an AC source of EMF 220 volts and a frequency 50 Hz. Calculate inductive reactance. You know that inductive reactance is given by XL is equal to omega L. Omega is 2 pi F into L. Substituting value of 2 pi F and L, we obtain the reactance of inductance to be 100 ohm. Likewise, problem number 4. An AC circuit containing a resistor of 60 ohm, an inductor of 1 Henry and a capacitor of 20 microfarad are connected in series. Calculate the resonant frequency. You know that the resonating frequency is nu r is equal to 1 over 2 pi square root of L into C. So substituting the value of 2 pi L and C, we obtain the value of resonating frequency is 35.6 Hertz. Problem number 5. An AC circuit containing a resistor of 100 ohm, an inductor of 5 millihenry and a capacitor of 10 microfarad connected in series, calculate the quality factor. We know that the quality factor is given by Q is equal to omega R L over capital R. Omega R, which is 2 pi nu R into L over R. We don't know nu R. So first let's find nu R. Nu R is equal to 1 over 2 pi square root of L C. Substituting the value of 2 pi L and C, the resonating frequency is found to be 710.7 Hertz. So to find out the quality factor, now we found out the resonating frequency. Substituting the value of 2 pi and the obtained resonating frequency into L divided by R will give you a quality factor Q is equal to 0.223. Problem number 6. In a series LCR circuit, R is equal to 10 ohm and L is equal to 0.5 Henry. Calculate the value of capacitance required to get a maximum current when the circuit is driven by an AC of frequency 100 volts. So we know that to get a maximum current, it should obey the resonating frequency condition, which is omega L is equal to 1 over omega C. So we know the resonating frequency, so which is 2 into 3.14 into omega, which is 100 frequency, 100 whole square into the inductance, which is 0.5 Henry. Substituting and calculating the capacitance or the capacitor is found to be 5.06 microfarad. Problem number 7. So the capacity of a capacitor is 0.5 picofarad. Find the value of inductance of coil to be connected with it for getting a resonance frequency of 1 megahertz. So at resonance, the condition is omega L is equal to 1 over omega C. In this case, I need to find L. Substituting the value of 2 pi and frequency into C, which is 0.3 picofarad, that turns out to be 0.084 Henry. Problem number 8. A transmitter operates at 1 megahertz. The oscillating circuit has a capacitance of 200 picofarad. What is the inductance and capacitance resistance of the resonating circuit? First, we need to find inductance and capacitive reactance. So, the condition for resonance frequency is omega L is equal to 1 over omega C. So, we know omega and we know about C. So, using this, we will find about L. So, L is equal to 1 over 2 into 3.414 into 1 megahertz whole square into 200 into 10 power minus 12. So, the value of the inductance is found to be 13 into 10 power 5 Henry. So, to find the capacitive reactance, we know that X is equal to 1 over omega R into C. So, which is omega R, what is 1 by 2 into 3.14 into frequency, which is 1 megahertz into capacitance 200 into 10 power minus 12. So, the capacitive reactance is found to be 795.5 ohm. Problem number 9. A coil of inductance 0.4 millihenry is connected to on a capacitor of 400 picofarad. What is the wavelength of this circuit tuned? We know that the resonating frequency is given by nu r is equal to 1 over 2 pi square root of L into C. So we know the value of L, we know the value of C. Substitute in this equation, then we will obtain, we are trying to express in terms, we will retain the powers as 10 power 7 divided by 6.2 into 4. Now, if we assume the velocity of the if C is the velocity of the electromagnetic waves, then the wavelength, the relationship wavelength, frequency and velocity is given by lambda is equal to C over nu. So, what is C? C is 3 into 10 power 8. Nu is 10 power 7 divided by 6.28 into 4. Substituting in this equation, we will find the wavelength to be 753.6 meter. Problem number 10. In an LCR series circuit, a sinusoidal voltage of a peak value 283, R is equal to 3 ohm, L is equal to 25.48 into 10 power minus 3 Henry, C is equal to 796 into 10 power minus 12 farad. Calculate the impedance current and the power dissipated at the resonating condition. You know that the frequency at resonating condition nu r is equal to 1 over 2 pi square root of L into C. Substituting the value of 2 pi L and C, that turns out to be 35.4 hertz. At resonating condition, Z is equal to R. The impedance found to be 3 ohm. The current, which is I nu is equal to epsilon nu over Z. So epsilon nu is nothing but epsilon naught divided by root 2 into R. So by substituting the value of epsilon naught and R, we obtain, I knew the current is 66.7 ampere and the power dissipated P is equal to R I nu square is equal to 66.7 into 66.7 into 3, that turns out to be 13,350 watts. So this is how you need to solve the problem depending upon the questions. So in the last sessions we learned what is alternating current, the basic definitions of alternating current, terms of alternating current, and LCR series and parallel circuit using J operator, and resonating circuit, and how to solve the problems. So this is for this session. Thank you all. Hope you have enjoyed this.